What is going on today? We're looking at the acetal formation from a carbonyl in acid. The reason it's an acid is because we have H+. The reason it's carbonyl is because you have your carbonyl right here. And you're going to notice that this problem looks a little bit different. So we're covering this part up. You're going to notice that this problem looks a little different than the ones you've seen before. You see that the carbonyl is in the reagents section, and the diol is in the starting material. It doesn't really matter as long as you have all these three combination of things, which is H+, carbonyl, and then this thing. That's still going to give you that product. So this might be a little scary at first. So let's break it down into something easier. Let's look at some stuff we already know. We know that you take the carbonyl and you have this diol, 2 alcohols on this thing, H+, it's going to give you this. It's going to give you the hat, okay? So let's think about this. Like, before we even try to work through this mechanistically, let's just try to think about it, because you're going to want to be able to do both. You're going to have to be able to do this on the reaction section if you were given just this, and you would also need to be able to show the mechanism. So we've already been through that, so we're going to actually just jump into this. So think about this one. So this molecule, what this really is just this. I draw it like this, and then I flip it to the side, and I draw the hexagon. So this molecule is the same as that, but now it looks kind of similar to the way we did this one up here. So imagine we just had this, you know what to do. So imagine we just have this, and don't even worry about that stuff yet. What would you do? Exactly. And now all you need to do is add the rest of it. So you turn it, or this is what I do. And there you go. And that's your product, which is the same as this, if you really look at it. Except this might make a little more intuitive sense based on the way we've been doing them. However, if you can see it this way, then more power to you. Then that really means you have good visualization skills. But if you flip this, turn it over, you would notice that it's this molecule. So I showed this demonstration ahead of time just to kind of give you an idea to be able to see these things, because you're going to need to be able to do both. So let's actually jump into the mechanism. Let's keep it this way, if that's all right. Because this, to me, it looks like a whole different thing, whole different ball game. So I don't want to play that game. I just want to play the game that I already know how to play. So we protonate. We got res. What happens? The alcohol comes in, right? We got our reversibility. So we have to remember your equilibrium arrows. Don't forget about those. So that's where we're at. So now you can either use the starting material, which is the carbonyl, to deprotonate, or you could use another molecule of this alcohol. I'm just going to use this carbonyl because it's a little smaller, a little easier to work with, because it's less to write. So that's like the first basic part. So like we did before, we want to be able to connect this other side down. We want to be able to hammer it down into, kind of turn it and then attach it. But in order to do that, we need to get this OH out of here. So one way to do that is to protonate it, turn it into a good leaving group, and then it'll leave. So let's go ahead and make that happen. I'm just going to rewrite it. You got that thing over there. It's going to get protonated. Good leaving group. So once you figure out a way to draw it that makes sense to you, I would stick with that way and force the reaction or force your mechanism to kind of obey your laws. So you see how I turned this to the side to make it easier, and then I just made it obey my laws? You can do that. So if it helps you to visualize it up like this, feel free to do that. Anyway, you have to remember you have a resonance form. So that's a positive charge right there. It's a little small. Apologies there, but you should know what that is anyway. So now let me redraw this structure. All right. So now we have our lone pairs on this alcohol. It's going to attack to and then you always want to be glancing up at our top structure, making sure that we're on track, which we are. All right, we're looking pretty smooth. We just need to deprotonate now, and luckily water left, so let's just go ahead and use that. Get the equilibs, get a little bit of that going. That's it. Simple as that. The way to learn these is to rewrite them probably 5 or 6 times over. Once you get good at it, you should be able to bang this out pretty quickly. So just keep practicing.